Okay, let's start off with a couple of review problems. These are my top 20. These are really important skills to know. Factoring, first one. I'm going to have you actually try these problems, and then we'll exchange them and grade them. So, okay, here we go for the grading. Do you agree there's a 2 in all of those? 2 comes out first. If you forgot that, you're already wrong. 2x squared minus 3x minus 2. Now you might say, but I found another way to factor it. Yeah, but your way isn't factored all the way. The 2 has to come all the way to the front. Now I can factor it a next step, which is to say 2x and x would multiply to make 2x squared. And then what two numbers make a 2? Well, it's got to be a 1 and a 2. I just don't know where they go. 2 and a 1, or is it a 1 and a 2? And one has to be negative and one has to be positive. I totally just guess, and it's okay, because I'll know in a second if I was right. Is negative 2x and positive 2x going to add up to 3x? No. So I did it wrong, and I was way off because 0x and 3x are not even close. So I reversed those two and put the 2 here and the 1 here. And now I check. Outside negative 4x, inside positive 1x, that makes negative 3. Yay, I factored it all the way, and there it is. Now, how many of you are grading somebody's where they had that one right? Raise your hand if your kid had it right. All right, so only 6 people really know how to factor in here. Do you get that that's really important? It is. This is something, if you can't do it, you're going to fail the test that we have that includes lots of factoring. That's why I'm practicing it now, so that when we get there, you'll be good at it. All right, this next thing, this is basically just doing things in the right order. And this one right here is our first part of the problem. And do I do the multiply by 3 or the power of 5? Power of 5. So I'm going to do the 5 first. This part right here. And that means a to the 2nd to the 5th. That means a to the 10th. And b to the 3rd to the 5th. That means b to the 15th. And that 3 really can't go with anything else because it doesn't have any other just plain numbers there. And then I bring down the rest of the problem. 2, and then this is like it's to the 1 power, right? So I'm just going to call it a to the 1 and b to the 3rd. It's like the parentheses just dropped off, and that's correct, because when you do to the power of 1, they pretty much do just drop off. And then the 3 can go with the 2 and make 6. A to the 10 with the a makes a to the 11, and b to the 15, and b to the 3rd makes b to the 18. How many of you are grading one where they had it right? Ooh, lots more people had that one right. That's good. All right, I'm still scared about our factoring abilities, but give the person a score of whatever out of 2. And get back to your spot, please. Okay, maybe that was enough instruction, enough of a little wake-up call to see if you remember factoring. And maybe you can do this now. Everybody try another factoring problem. I'll give you a hint. This one does not have any GCF. So you just jump right into the 2 parentheses thing and factor it from there. Pause while you do that. For those that aren't sure how to start, you always can go 5x and x. Those two have to multiply and make that. There we go. Now from there, there's just 2 numbers. You have to play with them and figure out where they go. Raise your hand if you think you've got it already. All right, good. So why did everybody get it wrong before? Did you forget to factor the 2 out at the beginning? Okay, good. Well, that makes me feel better about it then. Okay, so then this 7 could be either a 7 and a 1, and I don't know if I'm right or not. I'm totally just guessing. Let's find out. I go, first make 5x squared. My lasts make negative 7. Those are the easiest to check, so you may as well check them first. And then the outside and the inside is what it's all about, and that adds up to positive 7, negative 5 makes, am I even close? No, so then I switch it around. This 7 goes here, and this 1 goes here. Now the outside's negative 35, and the inside's positive 1. Hey, that's 35. That makes 34, and that's what I wanted. So yay, it's factored all the way. Raise your hand if you got it right this time. Okay, good. So factoring's huge. Be good at that. Now, why do we do that so much? Because almost always it says equals 0, and then you have to find the 2 roots, which would be 7 and negative 1/5. Okay, other thing you do with it is like this. You're in the middle of a problem, and it's got this on the bottom. Let's see. X squared minus 49. Do you know how to factor something like that? Okay, good. And what goes into Or how could you factor x squared minus 49 then? X plus 7 and? Yep. There, it's factored. Now what's cool? Sir? Good. Then I got 5x plus 1 over x plus 7. Right there's fine, thank you. All right, so that would be a good answer. Now, what we're doing today is a problem just like this, except we would ask you, what's the domain of your answer? The domain. What the heck does domain mean? Here's my answer, 5x plus 1 over x plus 7. Domain means the numbers for x that you can put in that will work and not crash. So here's a way to think of it. Almost everything always works in a function. Really what you should be thinking is, everything works except what wouldn't work in the function. Look at this function. What would crash my function? Not 7. You're close. 0 would not crash the function either. Negative 1/5 would make the top 0, but that does not crash the function. Yes? Nope, you're warm. Negative 7 is correct. I know you said it once before, but you also said other wrong things. So, okay, negative 7. Negative 7 is the thing that crashes it. Why? Because the bottom is 0. Can't have a 0 on the bottom. So that's what you have to watch out for on domain, is how could you make the function crash? Having a 0 on top does not crash it. Why? Because 0 divided by anything is just 0. It's okay to have a 0 on top. It's just the bottom that can't be 0. All right, let's talk about another way you can crash a function. So let's say I had this, square root of x minus 4. Do you get that there's some numbers I could put in for x that would be okay? Like big numbers. Like I could put in a 24, and then I'd have 24 minus the 4 makes square root of 20. Is there anything crashing about the square root of 20? No, it's a thing. Not necessarily a nice number, but I can do it. But what if I put in x is 0? Do you get that I'd have the square root of negative 4, and that's not a normal number? In fact, it's not a real number. It's imaginary. So therefore, if you put in 0, it crashes. So on a problem like this, you'd have to say, well, there's a whole bunch of things that would crash your function. So here's what you do. You try to figure out what specifically is the number that gets the closest to crashing it but doesn't actually crash it. Can you do that in your head? What gets this thing really close to crashing, as in crashing meaning square root of a negative, but doesn't quite make it crash? 4, you're right. Because if you put a 4 in there, it's going to be the square root of 0, which is incredibly close to being negative, but it's not negative. Can you do the square root of 0? Yes. So 4 is not a problem, but 4 is the number that gets the closest to crashing it without crashing it. Then would you agree that my answer has to be something related to the 4? Do we want it to be bigger than the 4, or less than the 4, or less than or equal to the 4, or greater than or equal to the 4? Here's how you do it. You take what's underneath the root, and you say, I want what's underneath the root to be greater than or equal to a 4. So I should clarify. I want to just take exactly what's underneath the root here, which is x minus 4. And I want to say, I want that to be greater than or equal to 0. This part right here needs to be greater than or equal to 0. Better write this one down if you're taking notes. Set denominator greater than or equal to 0. That's how you solve almost all today's homework problems. Set the square root part, I said denominator before and I was wrong. Set the square root part greater than or equal to 0. This is for square roots or radicals. Sometimes they use that name for square root problems. You just take what's underneath the root and say greater than or equal to 0, and then you solve it. Do you get it? I just have to add 4 to both sides, and then x will be greater than or equal to 4. There we go. That's the domain for this. That means the numbers that work are the ones that are 4 or bigger. If you put in a 4, it barely works. It turns into 0, and the square root of 0 is just barely legal. Anything bigger than 4 is going to be fine, like 5, 6, 7, 8, 9. They're all going to be fine. But if you put anything less than 4, like you put in a 3, it'll break. Because 3 minus 4 is negative 1, the square root of negative 1, broke a rule, can't have that. Okay? That's called the domain of this function. It's all the numbers that will work. And if you take numbers that are 4 or bigger, it'll work. So that's called your domain. Okay, the other kind is where you have a fraction and it's like this, 1 over x minus 9. Do you get that almost any number would work except what one number wouldn't? 9. So you'd say, I want x minus 9 to not equal 0, and I would be okay. Take your denominator and set it not equal to 0. That's how you get your domain when there's a fraction. All right? So then if I solve this, I go add plus 9, x cannot equal 9. That implies everything works except x cannot be 9. It can be anything else in the world except 9. All right, so here is 2 typical questions. I'm going to make it simple to start with here. This is problem 1, and this is problem 2. I want to know the domain of both problems. Remember, if you have square roots, you set them greater than or equal to 0. If you have denominators, you set them denominator cannot equal, the not equal sign, 0. Say I'm only going to get half the class to get even one of these right. So don't feel bad if you don't know. But after I show you the example, these 2 examples, you should be darn close to having it. Okay, show me just the top one. Zoom in on the top one really close and tell me what you think the answer is. Just the top one, please. You have to solve them. You're close, but you have to solve them. Oh, maybe you have. You just haven't zoomed in on just the answer. All right, cool. Good. You forgot the or equal to. Good. I have some people that aren't showing me. I'm assuming you don't know. Good. Okay, yes, except you have to solve that. So add 7 to both sides. I think it's supposed to be you divided by, no, I don't know what's happening, but let me show you. You don't set this whole thing to be greater than, you just set this part right here, just this part. X plus 7 needs to be greater than or equal to 0. Remember that? Anything that is a square root, you set greater than or equal to 0. So now I solve that and I subtract 7 from both sides. X greater than or equal to negative 7. Why didn't we switch the signs? I did a negative 7 on both sides, but I was, you're right, I didn't divide by or multiply by a negative. I just subtracted 7. All right, so there it is. X is greater than or equal to negative 7. That means any number in the world that is bigger than or equal to negative 7 will be okay. Every other number in the world would crash your function because you'd have a negative on the square root. Okay, this part, it's different. What do we care about here, the top or the bottom? Bottom. We set the bottom what? Not equal. No. X plus 3. I write what's here. I say x plus 3 is not equal to what? 0. Then you solve it and you can get the final answer. I get subtract 3 from both sides, and I get x cannot equal negative 3. That means everything in the world works except can't use negative 3. All right. Be honest, how many of you have gotten both of these right? And that's less than half of you. All right, good. So that's what I thought. Now I'll try this one. This is problem 3 for practice. 2 plus the square root of x all over 5. And problem number 4 is 5x minus 4 all over x plus 9. find the domain of those two. One of them's got a square root. One of them's got a fraction. By the way, just a little thing that could save you a ton of time in this class. I'm fine if you don't write down the original problem. The original problem's on the board. You don't have to write it again. Okay? If you feel more comfortable doing that, go ahead, but it is costing you time. Because we can just have you take the next step, which on problem 3, the next step is to take the square root part. Now, some of you might have been thinking, but it has a denominator. Can I ever make that denominator be 0? No, it's a 5. You can't stick a number in there. That's not a variable. So you don't have to worry about the denominator. You only have to worry about the square root. What's the rule for square roots? You set what's underneath them. X needs to be what? Greater than or equal to what? 0. So that's the answer, because there's no solving even needed here. X is greater than or equal to 0. Raise your hand if you had that one right. Okay, good. And the next one, I go to the denominator is the only thing to worry about, and I say x plus 9 not equal to 0, and then I solve it. X not equal to negative 9 then. Raise your hand if you had that one right. Okay, good. Now I can step it up a notch. 3 square root of 2x minus 1 is problem 5, and problem 6 is 1 over x squared minus 16. Remember, if you can factor it, you should. And pause for a second while you do that and take attendance. Okay, let's see on that first one. Did you say 2x minus 1 greater than or equal to 0, and then you solve that little thing? That's what you're supposed to do. You take that, you set it greater than or equal to 0. Then actually add 1 and then divide by 2. Final answer, x greater than or equal to 1/2. Raise your hand if you had that one right. Awesome. And the last one, a little tougher. Remember, I said if you can factor it, you should. X squared minus 16 is x plus 4 and x minus 4. So there's 2 things on the bottom that could cause me problems. Do you get that if the bottom is 4 or the bottom is negative 4, either way? So you take the denominator and you set it not equal to 0. You say x plus 4 and x minus 4, that's my denominator, not equal to 0. So what would cause it to be 0? The 2 things we have to watch out for is x cannot be 4 and x cannot be negative 4. Because those 2 things would both crash the denominator. So it's got two things you have to watch out for. Everything works in the world except x cannot be 4 and x cannot be negative 4. By the way, when you just say x cannot be 4, you're sort of implying, but it can be everything else. Right? You get that? And so the other thing you should do is write a big R next to it that's got 2 slashes, or 2 like up vertical lines to make your R, and that stands for all real numbers. So your official answer is all real numbers where x is not 4 and x is not negative 4. So again, let's prove that. That means 0 should work. A lot of people think 0 crashes everything. It does not. If we go back to my original problem here, which is that blue one there, x being 0 just makes it 1 over negative 16. That's an answer. It might not be a nice answer, but it's an answer. It doesn't crash it. 0 doesn't crash a lot of functions. But if you make the bottom, the whole bottom be 0, which would be like putting in a 4 or a negative 4, that's what would crash this thing. All right, that's the first half of the lesson. Now the other stuff that you need to know for today is this a function of that? Let me show you what I mean. E equals mc squared. It's a classic, right? Energy is equal to mass times acceleration. Does anybody know what the c in that is? The c in this, yes sir? Speed of light, that's right. Okay, E equals mc squared, and c is the speed of light. It's definition of c. All right, so in this function, I would say that energy is a function of mass and acceleration, which is c, or mass and the speed of light. This is a function of that. All right, here's another one. Area equals length times width. Area is a function of length and width. What if I wanted you to rewrite this formula so that length was a function of width and area? If I want length to be the thing that is a function of the other two, I got to get length alone. Divide by W, divide by W. Do you get now length is a function of area and width? If you solve it for that variable, this is a function of that. All right. Is y a function of x? Yes. The way you can answer this that I think is a folksy way to say it, but I think it helps you understand it. If I say y is a function of x, that means it'll have x's in the answer. You know, kids usually like an answer to come out to be like 7. Okay, but here y is 3x plus 4. It's got an x in the answer, see? All right, now how about this? This one, y is not quite a function of x because y isn't alone yet. So multiply by 2. And you multiply by 2 here and here and here. And now y equals 8 plus 2x. Now is y a function of x? Do you get why it wasn't a function of x before? Because it wasn't solved yet. All right, how about this? Make y a function of x. Just means it'll have an x in the answer. And it has to be solved for y. Okay. Hopefully you knew that anytime you have a fraction in your problem, you can start by clearing your fraction. So you times everything by 3. Doink, doink. 2y equals 12x. Then you can divide by 2. Y equals, divide by 2, divide by 2, 6x. Raise your hand if you had that one right. Okay, good. You made y a function. Y is a function of x now. Why wasn't it before? Because the y wasn't alone. Okay, how about this? Y equals 6x plus 7m. Is y a function of x? By saying x, I'm implying, is y a function of only x? No, it's not, because there's an m in there. What if I told you that m was equal to 4x? Would you be able to now write y as a function of x? Go ahead and do it and turn it my way, and let me see if you get it right. Make sure you simplify it all the way. Make it so y is a function of x. You just didn't add them right. Get the right idea. What did you say before? Okay, you just got to put them all together. Yes. Your numbers, you have x squareds. You don't want to make them squared because they're just being added. Like 7x's plus 9x's doesn't make x squareds. 7x's and 9x's would make like 16x's. Something like that. Just x's in your answer. Yes. Question? Yes, you may. Yes. Yes. Okay, everybody's getting it. Y equals 34x, because I put the 4x in here, and that makes 28x, and then you put the 28 with the 6, and you get a total of 34 x's. All right, that's making something a function of x. And the last thing we have to do is, just looking at a picture, you should be able to tell me if it's a function or not. Do you remember the little rule that if y is a function of x, you know, it has like something x, that it'll pass the something test? Here's a function. How do I know for sure it's a function? It passes the what? Vertical line test. Yes. A vertical line test means I just take a vertical line like this, and if it ever touches twice, then it doesn't pass the vertical line test. So that one passed. Function or not? Not a function, because it won't pass the vertical line test. And the official, the official way to say that is, well, it didn't pass the vertical line test is a safe thing to say. But it's also because this input of, let's say, x equals 3 right there. 1, 2, 3, you know, it's right underneath the 3 there. So if x equals 3, y is two different things. It's got one input giving you two different outputs, and that's not okay on a function. When you put in a number like 3, the machine should always spit out the same thing, and this time it spits out two different things. Sometimes it kicks out an answer of 2, and sometimes it kicks out the answer in -2. It may be a neato shape, but it is not a function. Okay, so all you have to do on that section is look at your graphs, see if they pass the vertical line test, and know that that really means that one input is giving two outputs if it's failing the vertical line test. Okay, and that's all I have for you for today. All right, so I'm actually still going to record a little bit more because I didn't explain range. All right, look at number 18 on the homework. It's about range. I have already taken my parabola that's from the x squared, and I flipped it upside down, and now I got to do that 10. Is that 10 positive or negative? 10 is positive, so I'm going to move it up 10. There we go. Generally, that's what my shape looks like. Now I'm going to actually just redraw it there because... Okay, there. Now tell me, what's the range of this thing? You should know how to do domain and range from last year, but in case you've forgotten, the domain, we do a different way, but the range, we do by looking at the picture, and we say from how low to how high. From -infinity is the lowest this thing would go to how high would this thing go. The highest it ever reaches is 10. It never touches the infinity, but it does touch the 10, so it needs a bracket around the 10. That's your range of this function, from -infinity to 10. It was easy once I saw the picture. Same with this one. So you sketch yourself a picture. You know what the parent looks like? I do. It's a square root graph. It looks like that. Now, it's got 4 minus the x. That means it's flipped left-right. So I have to take that thing and flip it left-right, which will look like that. There, now I just did the negative. Now that 4 on the inside there, that 4 is positive. And therefore, this whole thing should move up 4. No, wait, that's a left-right thing. Left plus 4 means left 4. Okay, and the last thing is that plus 5, which is up 5. Whew. Hardcore. There. Now that I've got my shape here, and it stops here, and it goes forever this way, now I should be able to say, what is this domain and range? Well, the domain they already asked in a different section. So all I care about right in this problem is the range. The range is from how low to how high. And how low does this thing go? Be careful now. Is it the 4 or is it the 5? Which one did I move the up, down? Yes? The 5. It's the 5. So it's from 5 to how high will it go if I extend it forever? Infinity. So this range is from 5 to infinity. And it'll touch at the 5, and it goes forever, so it'll never touch the infinity. Okay, there's your range on that one. How did I get it? By sketching it. That's about right there. Is at -4, 5. And people get the 4 and the 5 confused all the time. On range, we're thinking about the y's. That's why we use the 5 here. So range is about y, domain's about x. So for these last couple here, just sketch them. And once you got the sketch, it'll be easy to see what the range is. All right. This assignment's a little long. I'm okay with you guys skipping 16 and 17. I think those may be a little more intense than we need them to be today. Number 15 is kind of easy if you look at it, but a lot of people are going to screw this up because they're going to think you can factor that and make it equal 0. You cannot. because it's x squared plus 1, that does not factor. X squared minus 1 would have factored. X squared plus 1 does not factor, and therefore that part right there that I circled in green can never equal 0. All right, so there you have it, your first day of new material in the new section, because we just ended up testing the other day. So if you were gone on Friday, you missed getting your test back, I'll give those to you later. Now that's really all I have for the video.